Hello students, welcome back to lecture series on numerical methods or numerical solution of ordinary differential equation. Already I have explained plenty of the method guys in my channel. So if you are interested to see this video, go and check in I button over here or you will get in description box. Okay. So in my today's video guys, I'm gonna explain to you all one of the example based on Kutta fourth order method. Already for the second order method and it's an example I uploaded in my channel. Okay, about fourth order method and it's an example. Okay, method I also uploaded in my channel. Okay, so if you are interested, go and refer these videos. Okay, yes. So in our today's video guys, we are going to understand one of the example in detail. Okay, Kutta method for fourth order. Okay, for finding the value of y, where the function it is given. I explained same example for the second order method. Okay, but fourth order method, this example repeated plenty of the time in your exam. Okay, so without further ado, let's get down into our today's lecture. I'm gonna explain to you all example and then we go for the solution. Okay, so what we have given in an example: use Kutta formula of a fourth order to find out the value of y whenever x is a 0.1 and x is a 0.2. Given that we have given dy by dx as a differential equation x plus y with the initial condition y of 0 which is equal to 1. Okay, so we have two initial conditions. One initial condition y of 0 is a 1 over here, and for the value 0.1 and 0.12. Okay, we have to take two different iterations for our Kutta fourth order method. Okay, yes. So without further ado, let's get let's get start this solution. Okay, so what we have given dy by dx as x plus y. We have given here dy by dx as a x plus y. This means dy by dx as a f of xy. Okay, so we got it here dy by dx as a f of xy. This implies f of xy as a x plus y. F of xy as a x plus y. This one is our function f of xy as a x plus y. So y of 0 which is equal to 1 given. Okay, y of 0 which is equal to 1, and we know that y of x naught which is equal to y naught, which is the initial condition for our differential equation. So x naught we take 0, y naught we take 1. Okay, x naught is a 0, y naught is a 1. That we needed in our Kutta fourth order formulas. Okay, so I got the value for x naught or y naught. Okay, so we have two different values. X is a 0.1 and x is a 0.2. Okay, so for this first value we are going to find out the first iteration, and the second value we are going to find out the for the second value we are going to find out the second iteration. Okay, yes. And about the value for h we are taking as a 0.1. Okay, so as we are starting with the x as a 0.1, so we will get the approximate. Okay, we get the approximation value h as a 0.1. So okay, we take h as a 0.1. So these are the basic value that we needed here for our Kutta fourth order formula. Okay, yes. So let me write the Kutta fourth order formula that we are going to use here for the solving this example. See that guys, these examples are very much important. Watch these videos very carefully. So y1 which is equal to y naught, y1 which is equal to y naught plus 1 by 6. Okay, 1 by 6 k1 plus 2 k2, k1 plus 2 times k2 plus 2 times k3 plus k4, k1 plus 2k2 plus 2k3 plus k4. Okay, this is our Kutta formula for fourth order. Okay, that we have to use here for the solution. Okay, now see that y1 for finding the y1, and we have to go for the y2 also. Okay, because as we have x is a 0.1 and x is a 0.2, that means we are taking x as a 0.1, that means y of 0.1. so for y of 0.1 we use this formula. Again y of 0.2, again we use similar formula. Okay, but only the difference is that in our second iteration for y of 0.2 we will take all the value that we will get it from this formula. Okay, at our first iteration. Yes, so let's find out the value for k1, k2, k3, k4 and put all this value here. Why not? Already we have 1 here, so not to worry about why not. Okay, let's go for the k1, k2, k3 and k4. Okay, so we know that the value for formula for k1. Okay, so k1 we write h of x naught y naught, h of x naught comma y naught. This one is our k1. Okay, so h of x naught y naught. So we have f of x y is x plus y. Okay, so we want f of x naught y naught. X naught is 0, y naught is 1. Okay, f of x y we have x plus y. Okay, and we want f of x naught y naught, that means f of 0 1. Okay, so we write f of 0 comma 1 as a 0 plus 1 which is equal to 1. Okay, so I got the value for f of x naught y naught is a 1. Okay, and h is a 0.1. so I'm going to write k1 as a 0.1 multiplied by 1. Okay, so this gives k1 is a 0.1. Okay, so I got the value for k1 as a 0.1. So again we'll write the value for k2. Okay, we will write the value for k2. Okay, k2 we know that h multiplied by f of x naught plus h by 2, y naught plus k1 by 2, x naught plus h divided by 2 plus comma y naught plus k1 by 2. Okay, this one is our f of x naught plus h by 2, y naught plus k1 by 2. K1 you have to take it from here. Okay, so it is only we need to find out the value for f of x naught plus h by 2, y naught plus k1 by 2. Okay, yes, so let's find out the value for f of x naught plus h by 2. X naught, what is the value for x naught is a 0. Okay, 0 plus h by 2. H by 2 means 0.1 by 2, 0.1 divided by 2. Okay, 0.1 divided by 2 comma this is f of x naught plus h by 2 comma y naught. What is the value for y naught? Y naught is 1 plus k1. K1 what we have? K1 is a 0.1, 0.1 divided by 2. Okay, bracket complete. I hope you all have understood how I have written these values. Okay, not that difficult guys, I just need to go for the basic calculations. It's very easy. Okay, so I'm going to write this one in the simple form. 0.1 divided by 2 we write it 0.05, f of 0.05. okay, f of 0.05. 1 plus 1 0.1 by 2. Okay, so 0.1 divided by 2 0.05 plus 1, that means 1.05 comma 1.05. okay, this one. Okay, so we want this one 0.05 plus 1.05, that means f of x y is x plus y. That means add both of them, you will get the entire value as 0.05 plus 1.05. okay, so add both of them, you will get the value. Let me put this value in our formula. Okay, k2 which is equal to h is a 0.1. okay, under bracket f of x naught plus h by 2, that means f of this comma this, that means f of this plus this. Okay, so we write 0.05 plus 1.05, 0.05 plus 1.05. okay, add both of them, multiply to the 0.1. okay, so you will get the value as a 0.11. okay, so I got the value for k2 as a 0.11. okay, I got the value for k2 as a 0.11 over here. Okay, add both of them and multiply here, you will get the value for k2. Okay, so similarly find out the value for k3, k4 and replace it here. Okay, so what is the value for what is the formula for k3? K3 it is our third constant. Okay, h multiplied by f of x naught plus h by 2 comma x naught plus h by 2 comma y naught plus k2 by 2, y naught plus k2 by 2. It's very easy guys. Okay, x naught plus h by 2 and y naught plus k2 by 2. So we know that x naught plus h. Okay, x naught plus h by 2 it is a 0.005. okay, only the value for y naught plus k2 by 2 this will be changed, this will be changing. Okay, yes, now see that h is a 0.1 multiplied by f of x naught plus h by 2. okay, 0.05 comma y naught plus k2 by 2. okay, so what is the k2 we have 0.11. okay, that means 1 plus 0.11 by 2. okay, 0.11 divided by 2. Okay, put these values, you will get the, after put this value, this plus this, if you're going to add this one, okay, 0.1 under bracket multiplied by 0.05 plus 1 plus 0.11 by 2. Use your calci guys, find out the value for K3. Okay, so you will get the 0.1105. this is the required value for K3. Okay, this one is the required value for K3. I hope you all have understood guys. It's not that difficult. Okay, just need to replace the values, so it's our last part, it is remaining, the value for K4. Okay, so what is the value for formula for K4? Okay, so K4 can be written as h of x0 plus h, y0 plus K3, x0 plus h comma y0 plus K3. Okay, replace the values, you will get very easy answer. Okay, so 0.1 multiplied by f of x0 plus h. X0, what is the value for x0? X0 is a 0. 0 plus h means we have already x0 plus h as a x0 plus h. Okay, we have already the value for x0 plus h as a 0.1. Okay, that we already found this one, 0.1 x0 plus h. And y0 plus K3, y0 what we have, 1, y0 is 1 plus K3. Okay, 1.1105 comma 1.1105. this is just the substitution of the value guys. Okay, you can easily do this. These are the 5 marks question. Okay, and just these are the simple calculation. If you follow it as per the process, you will get the out of marks here. Okay, yes, so multiply everything, you will get the K4. Okay, you will get the value for K4 as 0.12105. Okay, 0.12105. this one is a required value for K4. Okay, I hope you all have understood guys, value of K4 over here. Okay, so our last target here to find out the value for y1 as our first iteration. Y1 is equal to y0 plus 1 by 6 K1 plus 2 K2 plus 2 K3 plus K4. Okay, so as we have all the value we present over here, now need to replace these values here and find out the value for y1. Okay, so what is the value for y1? Y1 which is equal to y0 plus 1 by 6 under bracket K1 plus 2 times K2. Okay, K1 plus 2 times K2 plus 2 times K3 plus K4. this is the value for y1. so replace the value for y1 which is equal to y0. Y0 we have here as 1. Okay, 1 plus 1 by 6 under bracket K1 plus 2 K2 plus 2 K3 plus K4. Okay, so I'm going to replace the value directly. K1 as 0.1 plus 2 times K2. 2 times K2 means K2 we have here 0.11 multiplied by 2, 0.22. You will get the 0.22 plus 2 times K3. We have K3 is at 0.1105 multiplied by 2. So we'll get the 0.2210. 0.2210. Okay, plus, and what is the value for K4? 0.12105. 0.12105. Okay, this one is the value for K4. Add all of these values guys, you will get the value last y1 value. Okay, 1.11034. 1.11034. Okay, 1.11034. this one is our last required value. Okay, I hope you all have understood guys, how I have solved this example. It's not that difficult. You can see here the value for y1. Okay, with respect to x as a 0.1, that means we found the value for y of 0.1. Okay, so our next task here to figure out the value for y of 0.2 as x is a 0.2 here. Okay, so we have to repeat similar process, but only the change here we are going to take the K1 K2 all these values from here. Okay, all these values from here for our next x as a 0.2. Okay, it's very easy guys. Okay, I hope you all have understood this first part. Okay, let me solve for the second part now. So see guys, here I have written these values that we found earlier in our previous part of the example. Okay, now in our second part of the iteration we are taking x as a 0.2. Okay, that means we are finding the value of y of 0.2. okay, yes. Now see that for our Rankutta fourth order method we needed x naught, y naught, h. Okay, this value we needed here for finding the beginning iterations. Okay, so that I return this x naught. Okay, now see that x naught and y naught, these are going to change here. Okay, as per our previous part of the iteration. Okay, so now see that we write this one x naught as a x naught plus h. Okay, so at our first iteration we take x naught. In our second iteration we take x1 as a x naught plus h. Okay, but I am not going to add x1. Okay, it will be the confusing for our formula. So better than this, what you do guys, okay, instead of taking x1 you take x naught as a x naught plus h. Okay, for our second iteration. Okay, so this one is x naught plus h, means x naught is a 0 and h is a 0.1. so x naught plus h is a 0.1. and y naught we also want the y naught. Okay, so the last value y1 which we received here. Okay, so that is the value for y1. At the end we got the value for y1. Okay, 1.11034. so this are going to pretend as a y naught. Okay, this is going to pretend as a y naught. so instead of y1 I'm going to consider it as the y naught. Okay, as a 1.11034 for our Rankutta fourth order method, and h is a 0.1. Okay, so let's replace all these values in our Rankutta formula. See that this is our Rankutta fourth order formula that we are going to replace all these values here. y1 is equal to y naught. Now y naught I'm going to take this one over here. Okay, with respect to x as a 0.2. okay, so 1/6 it is constant. K1 we are going to find it here, and x naught, y naught. X naught it is 0.1, y naught you have to take it from here, and h as a 0.1. okay, yes. Let's find out the value for our K1. Okay, yes. So how I'm going to write K1? See carefully here. So K1, h we have here 0.1. Not to make any changes. Under bracket f of x naught, y naught. Okay, f of x naught we have here 0.1. okay, and y naught is a 1.11034. 1.11034. okay, this is f of x naught and a y naught. Okay, and we know that f of x naught as y naught as a x naught plus y naught. Okay, so 0.1 we have in our example given function 0.1 plus 1.11034. okay, 0. Y of x, y we write x plus y. Okay, it is already given in our example. Okay, 1.11034. add all of these values guys, you will get the value for K1 as 0.12103. okay, 0.12103. 0.12103. okay, this one is our value of K1. okay, this one is the value for K1. Similarly we have to go for the value of K2. okay, so the value for K2 in our Rankutta fourth order formula. Okay, let me write the value for K2. h f of x naught plus h by 2, y naught plus K1 by 2, x naught plus h by 2, and y naught plus K1 by 2. okay, so replace all these values here guys. Okay, so what is the value for h? 0.1. f of x naught plus h by 2. x naught is a 0.1 plus h by 2, 0.1 divided by 2. okay, comma y naught we have here 1.11034. 1.11034 plus K1 by 2, that means 0.12103. 0.12103 divided by 2. okay, this one is a bracket complete. So this one is the actual value for K2. okay, so put this value in your function f of x comma y as a x plus y, and so you will get the value for K2 as, okay, I'm going to take little shortcut here because the process it is similar like a previous one. Okay, so don't need more explanation, you can understand this one very easily. Okay, yes, so you will get the K2 as a 1.3208. this one is the value for K2. So I got the value for K2 as a 0.13208. okay, Yes. So similarly go for the K3. Okay. So we know that the Runge formula for K3, we write K3 as h times f of x naught plus h by 2 comma y naught plus k2 by 2. Okay, bracket complete. Okay, now see that f of x naught plus h by 2 and y naught plus k2 by 2, this one is the value for k3. Okay, so we all are having all these values. Okay, so let's go for finding the value. Okay, f of x naught plus h by 2 and y naught plus k2 by 2. So k2 you have to take it from here, y naught we have already here, x naught plus h by 2, we have already x naught is a 0.1. Okay, let me write the value 0.1 under bracket f of x naught is a 0.1 plus h by 2 0.1 by 2. Okay, comma 0.1 plus 0.1 by 2 and y naught plus y naught we have here as a 1.11034 1.11034. Okay, plus k2 by 2. Okay, so what is the k2? So we want the k2 here, we have the k2 here 0.13208 0.13208 divided by 2. Okay, bracket complete. Okay, so just go for the finding all of these values. Okay, so we write it 0.1. Okay, so 0.1 plus 0.1 by 2. Okay, 0.1 plus 0.1 by 2 we write 0.2. Okay, that means f of x comma y is x plus y. Okay, directly I am taking the value, their addition x plus y. Okay, add both of them and write down this value here. Okay, 1.0. Okay, this one is a 0.15. Sorry, it is a 0.15. Okay, this is a 0.15. Okay, for the value of k3, and if we add both of them and we use it to our formula, so we write 1.17638. Okay, bracket complete. Okay, so after their multiplication we write k3 as 0.13263 0.13263. Okay, this one is the value for k3. Okay, so I got the value for k3 over here 0.13263. Okay, this is the value for k3. Let's go for the value of k4. Okay, so the Runge fourth order formula for k4 for our Runge fourth order formula, we write h time f of x naught plus h by 2 comma y naught plus, sorry, it is not h by 2, it is only h of x naught plus h, y naught plus k3. Okay, x naught plus h and y naught plus k3. Just need to replace the values, guys, here. Okay, h is a 0.1. Okay, f of x naught plus h. Okay, x naught plus h, x naught is a 0.1 plus h is a 0.1 plus 0.1 we write 0.2. Okay, so f of 0.2 comma, okay, f of 0.2 y naught plus k3 is here, y naught is here. Okay, 1.11034 and 0.13263. Okay, so add both of them, you will get 1.24297. Okay, 1.24297. f of x comma y, we write f of x plus y. So 0.1 under bracket 0.2 plus 1.24297. Okay, add both of them, multiply here, you will get the k4 as, you will get the value for k4 at 0.144 0.14429. Okay, this one is the actual value for our k4. Okay, so put all these values in our y2, guys. Okay, so what we have next, another value y2. Okay, y2 means y of 0.2. Okay, y of 0.2. So we write y naught plus 1 by 6 k1 plus 1 by 6 k1 plus 2 times k2 plus 2 times k3. Okay, plus k4. Okay, this one is a y of 0.2, that means y naught plus 1 by 6, remaining all the values. Okay, so y naught. Okay, so what we have y naught is, it is a 1.11034, 1.11034 plus 1 by 6 under bracket k1 plus 2 times k2 plus 2 times k3 plus k4. Put all these values here, guys. Okay, all these values here, and you can do it these calculations. Okay, so after finding the values, you will get the y2 as 1.24279. Okay, 1.24279. This one is your y2. Okay, that means this is a y of 0.2. This one is your required answer, guys. Okay, I hope you all understood this Runge Kutta method for fourth order. Okay, which is one of the easier, guys. Don't have anything. Just you have to take two different iteration. Okay, you have to take two different iteration for the two different values for 0.1 and 0.2. Okay, so I hope you all understood entire my solution here. So if you want, you can note it down, pause the video, guys. Okay, and note it down all the parts. Please see that my solution started from here. All this is given from our example. Okay, so if you want, you can note it down. Just see, this one is a fourth order Runge Kutta formula, so which introduced by k1, k2, k3 and k4. So after getting all this value, replace over here. Okay, so you will get the y1 as this 1.11034. Okay, so if you want, you can pause video, note it down all this solution. Okay, and similarly I repeated the process for x as a 0.2, but only the confusion part here, guys. Okay, x naught as a x naught plus h, y naught as a y1. Okay, this one you need to remember. Okay, so if you are still confused, let me know, guys, or you can see this video one more time again, so you can understand this concept very easily. Okay, yes, so if you want, you can note it down this remaining part. Okay, see this one, it is one of the easier, guys. Okay, yes, I hope you all have understood this entire part of my solution. If you find anything difficult, confusing, let me know in my comment section, guys. I will come up with the similar videos. So that's it here for my today's lecture. So thank you, everyone. Thank you for my today's lecture.